Hey there, in this video we are talking about structure initialization, putting structures in arrays, and also structure nesting in C++ programming. And this covers sections 11.4 to 11.6 in the Gaddis textbook. So remember what structures are from the last lecture? They are packages of multiple types of data that are somehow interesting or describe some coherent structure that we're interested in our programming. And among the primary themes in this chapter is that when you make a structure, you have made a new fully formed data type. Just like int or float or char, now maybe you have a type called student. That was one of the examples in the last lecture. And I think a student structure had an integer for the student ID number, a string for the name, a short integer for the year in school, and then a double for the GPA, right? All packaged together. And then you could treat it as one single type and one single variable together and make your programming somewhat more efficient. So again, a new type. Pretty much anything you could do with an int, you can do with your structure like student now, and we're kind of building on that theme day after day. Okay, let's talk about the first one there, initializing a structure. When you declare an int, can you assign a value to it right then? The answer is yes. So you can do the exact same thing with a structure. Again, that's called initialization. So a struct variable can be initialized when defined. Now to do that with a structure, you're going to use curly braces. Kind of like an array initializer, if you remember that, right? Very similar. So the values in the list, in the initialization list in the curly braces, are assigned to the fields in the same order as the structure definition. So if I make a student structure from last time, right, the type is student, the name is S. I would have given it a more sophisticated name, frankly. 4 things in the curly braces, and the first thing apparently goes into student ID because that was the first member in the structure definition. This thing, Joan, is going to go into the string member, the name member, which is a type string. This will go into year in school because that was the third item, and 3.75 will go into the GPA member because that was the 4th item in our definition. If you look back in the book or the last video, that's the exact order that we defined them in, and that's the exact order that you have got to put them in the curly braces to match up with that. Now, here's a little detail. Like, what would happen if my initialization had only had 11465 and Joan and nothing else? If the structure has more fields than the initialization list, then the remaining fields are left uninitialized. So in that case, the remaining stuff would have random garbage, right? If I just had the first 2 here, you get a legitimate number in student ID, a legitimate name in name, and then the year in school and the GPA would have random garbage. Okay, and that's fine. You know, maybe you're about to sin into that. Maybe you're doing some calculations and assignments in just a second, and that would be perfectly fine if that's what you were doing. So some examples of that. This is program 11.3 in the book, and they have a structure called employee pay. It's very similar to the one we saw last time, I think in program 11.1. So the employee pay structure has 5 members for name, employee number, pay rate, hours, and gross pay. That might be exactly the same as last time. And so here in the main function, we are initializing 2 employee pay variables in exactly that way. So we're making employee pay employee 1 and passing in Betty Ross, which will go into name because that's the first thing. 141 would be the employee number. 18.75 would be the pay rate. And currently, the hours and the gross pay are uninitialized, and so they're random garbage. And presumably, like later on, the employee actually has to come to work, and then we'd record how many hours they worked, and then we would compute the gross pay, but that won't happen until later. And then, of course, we're making an employee pay variable called employee2, and initializing the first 3 fields to Jill Sandberg and 142 and 1750. So a good example of structure initialization is what that is, using an initialization list, very similar to arrays. Hopefully that's pretty familiar to you. Okay, second thing. Can I make an array of a whole bunch of integers? Yes. So can I make an array of a whole bunch of structures? Yes, absolutely. Structures can be defined in arrays. Here's an example declaration. Of course, you want a constant integer like we normally do to track the size of the array. Here we're making a constant called numStudents, which is 20. And here on this line, I'm declaring an array of type student. So the type is student. The name of the array is StuList, which I presume is short for student list, which is a pretty good name actually. And the size of the array is numStudents. So I have just made 20 separate student structures in memory, which themselves hold 4 or 5 member fields individually. So that's actually a pretty powerful statement there. Now, once you've done that, individual structures are accessible using your standard subscript notation, just like you do for any other array. Let's take a look at that. Okay, so again, focused on that declaration of student, stu list, num students, right? An array that's got 20 student structures. So what you just did here is you made a whole bunch of student structures. There's stu list subscript 0 that has its own student ID and name and year in school and GPA. And then right after that in memory, you've got stu list number 1 with its 4 member fields, and you've got stu list number 2 with its 4 member fields, and so on and so forth, up to stu list number 19, of course. And each of them have their own 4 member fields to store and retrieve data in. So to access fields, you need to name the array, you need to give what subscript you need in square brackets, and then you put down the dot and you identify what member field you're interested in. So basically, at each step of the process, each step of your expression, you're digging into more detail. Name the array, what number do you want, what field do you want in that particular structure. So you might see something like this. When you want to print out, student number 1's name, you'd write stu list, that's the array name, bracket 1, that's the subscript, and then dot name, and you'd specifically be getting this member data right here, right? Stu list number 1's name is what you'd get. So, consider what we've had to do in the past. If you go back to programming 1 in our sequence at CUNY Kingsborough, programming 1, when we first presented arrays, we said, let's say, there's actually an example back there that said, let's say you've got a company and you want to store information about your employees, like their name and their ID number and how many hours they worked and what their pay rate is. And at the time we said, you're going to have to use 4 separate arrays that we call parallel arrays. 1 for the name, 1 for everybody's ID number, 1 for their pay rate, and so forth. 4 separate arrays called parallel arrays. And we probably hinted at the time that there was going to be a better way to do that, and this is the better way to do that. So now I don't have 4 separate arrays. I just have 1 array. And it's easier to declare, and it'll be easier to remember and easier to manage. Just having 1 array will certainly be easier than having 4 separate arrays. And in addition to that, the danger of parallel arrays is you got to make sure the sizes match. You could possibly missize one and have one bigger than the others, which would be a problem. You got to keep the subscripts in sync. So employee number 1 in the names array is the same as employee number 1 in the pay array. And if that gets out of sync, you have trouble. Working with multiple arrays, now you have multiple buffer overflow risks, et cetera, et cetera. So how much better is this? If you're interested in information about one person, just put it all in one structure. And that package will be very solid. It won't be a brittle data structure like parallel arrays. And this here, putting structures in one single array, much, much better. So we should definitely expect to do this all the time going forward. I'm glad we're finally here. Honestly, in the past, when I have to talk about parallel arrays, because we didn't have time to talk about structures, it kind of hurt me a bit because it's not great. This is what you want. Example of that, we have program 11.4 here. The structure is called pay info, just a very small little structure for an example. You have an integer for hours worked for an employee. You have a double for their pay rate. It's a pretty common example in this book here. And so in the main function, you start off declaring data. Here's a constant for the number of workers in the company. It's 3. And then the interesting thing on line 15 is the array being declared. What type is it? Pay info is the type. It's not integer. It's not double, right? The type is pay info. The name of the array is workers. And the size of the array is num workers, which is to say 3. Okay, just one single line there, and we declared 3 separate pay info structures, each with their own 2 members. So now we'll go through an input processing output part. And in each case, of course, the efficient thing to do with arrays is to use a loop to process them. So I'm sure we're about to see that. So here's the input part at the top, right? Prompt the user, enter the hours worked by your 3 employees and their hourly rates. So you've got a loop going over all 3 things in the array. And you prompt for the hours worked in each case, and look very carefully at line 27. one employee after the other, you send into workers, that's the name of the array, index, that's the subscript, and then dot hours, that's the member field, right? So the array and the subscript and what field you want. And then likewise down on line 32, you're sending in to get their pay rate. And you name the array, which is workers, and you indicate the subscript, which is the index in this for loop, and then dot what member you want. And that kind of thing happens over and over again. So there's your input loop that fills out the entire array with all three structures. And then it comes down here and they're going to process and print at the same time. Now, again, I would have separated these things out to separate functions myself, but I guess we haven't covered passing structures into a function yet. So I guess we can't talk about that yet. But this program could be improved in a day or two. So anyway, prints out here is the gross pay for each employee. Another loop to process everything in the array. And here you make a double variable called gross for that worker's gross pay. Here's the processing. You go to workers index hours. Again, the array, the subscript, the member, times workers index dot pay rate. The array and the subscript and the member. Again, multiply those together. That's obviously the gross pay, and you print it out. And again, that loop happens for all three employees. So if I go back just a second, how nice is this? If my company grows and now I have 12 employees, what do I have to change in this program? Just line 14. That's it. Just change that 3 to 12. And now your array will be size 12 and you're making 12 structures instead. And this loop will happen 12 times and this loop will happen 12 times. And very efficient if you need to possibly change it. I don't need to change 2 or 3 or 4 different arrays. I just need to change one. And let's test this program 11.4 here. So I've brought that up in the IDE. Now remember, I'm usually going to have my classes tab on, usually now when I'm dealing with structures or classes. And that's Dev C++ helping us out by reminding us what's in one of the key structures in the code. So if I get working further down in kind of a large code file, and I need to remember what's in a pay info structure, I can just look over here. And I don't know if I'm working down on line 42, I see, okay, I'm using hours, I'm using pay rate. Is there any field that I'm forgetting about? No, that's actually everything that's in that particular structure, plus a whole bunch of other cases like that. So I usually have the classes tab up. That's fine. Let me compile this. Great, no errors. Let me run this and see what it does. Not too hard to guess what this is going to do. So it's saying enter the hours worked by 3 employees and their hourly rates. And for each of the 3 employees, of course, we're going to fill in 2 pieces of data for a structure for each. So maybe the hours worked by employee number 1 is 40, and they make $20 per hour. And then employee number 2 worked 30 hours, and maybe they make $12 an hour, perhaps. And then hours worked by employee number 3, maybe they worked 35 hours and they're making $25 per hour. Great. Okay, so if I scroll up just a little bit, see what my input was. I got this. So here's the gross pay for each employee. Employee number 1, $800. That's right. Employee number 2, $360. Looks good. And then employee number 3, 35 times 25 is this. So that looks like that. Again, that's working correctly. Great, so it does properly store all this information in 3 separate structures in an array. Pretty efficient way of doing that. Okay, let's, one more time, let me run this in the debugger and see what it looks like when you have an array of structures. I'm not sure what this is going to look like. So I'll flip over the debug tab. I'll set a breakpoint. I will start running this in the debugger. So as usual, it is running, but paused on that line 14 where the breakpoint is. And what I'm really interested in is what does it look like when I put the workers array in the watch. I hope you remember, like for fundamental data types, when there's just one type in the array, it shows you curly braces and then value, comma, value, comma, value, comma, right, the whole thing. Now this is a little bit more complicated. So for what it's worth here in Dev C++, and maybe another ID does different, right now, it's just showing me the very first member, right? That workers array has got 3 separate structures in it. So curly braces saying, here's the 3 separate structures. And then one of the structures is indicated by more curly braces. And right here, it's just showing me the very first structure with its hours and its pay rate. And of course, to begin with, it's got random garbage in it. If I want to see the second one here, I have to hit this down arrow, because if I have a really huge array, I didn't want to fill up the whole screen with a whole bunch of stuff I didn't want to inspect. So maybe you just wanted to see the first one to begin with. But if I want to, I can see the second structure, and I can also see the third structure, and then of course that's it here. And to begin with, they all have random garbage to begin with. All right, so I mean, I could have imagined a better interface, or maybe this is a little hard for Dev C++ to handle, but there are the 3 separate structures. So I'm just going to go through, I'm going to set another breakpoint down here, and I'm just going to go through full speed through the input part and see what happens. So I'll hit continue and just go full speed through this. So the hours worked by employee number 1, I'll try to use the same example from before. 40 hours, $20 per hour. And then we had 30 hours and $12 per hour. And we had 35 hours and $25. Okay, so I've paused it again on this other breakpoint, and it collapsed for a second. But if I expand it, right, there's all the data that I entered, the 40 and 20, 30 and 12, 35 and 25 in the 3 separate structures, and they are all visible there. And then the program will, of course, go through the output part. And, I should put a watch on gross, because this gets computed with 3 separate things, of course. So there's the gross variable here, and we're about to run line 42, where it's taking from index 0, which is the very first structure, right, the 40 and the 20. Remember, when you're getting at data inside an array of structures, you're going to have to name the array, give the subscript, and then dot what member you want. So we've said that a couple times. I'm trying to get people to remember it, of course. So that happens the first time, and gross becomes 800, and it gets printed out. And you go back to the loop, of course, and now index will be 1, and you multiply the next one, and now gross is 360, and that gets printed. There we go. And then the last time here, of course, gross becomes that 875 number, and then that gets printed. And you're done processing all 3 structures in that array. Great. You notice that when things change, Dev C++ tends to collapse what you're looking at in the tab up here. So once in a while, hypothetically, if you're in the debugger, then you might have to go back and reopen stuff. Maybe that'll be improved someday. Okay, and the third thing today, nested structures. So can I put an int member in a structure? Yes. So can I put a structure member in a structure? Also, yes, absolutely. So a structure can contain another structure. That's what we mean by nesting, right? Take one thing and put it in another one of those things. That's nesting. So here's an example where we've made a struct called person info to store basic information about any person. You got a string for their name, and a string for their address, and a string for their city. And that's kind of a good example of declaring multiple things of the same type on one line. That's perfectly fine. So that person info structure has 3 members. And then later on, I'm going to define another struct called student that has an integer for student ID. It has, I'm going to come back here, it has a short for year in school, it's a double for GPA like we've seen before, but it has another member that's of type person info, which is this thing we declared up above, right? That type there is person info. And that P data for personal data itself is going to hold 3 members inside it, which is called name and address and city. Now, if you do that, now you're going to have to start stacking up multiple dots as you dig into more detail. So now, if I declare a variable of type student called lowercase s student, that's not a bad way of naming variables, right? It's actually pretty common that you'll have a type called student uppercase s, and then if you just need to make one single one of those variables, why not call it student lowercase s, right? It'll be very clear what it is. Any normal programmer can see the difference between the type and the variable. So I tend not to try to get too creative with my variable names. If I just have one, name it the same as the type, but lowercase. So once you have that, as you want to dig into the data that's in that student variable, you're going to have to write student dot pdata, and then digging into that dot name, and then you could set that to Joanne. Or you could print it out, or you could getline it, or whatever you want. Why would you want to do this? Okay, well, I mean, I have a lot of persons in my database. If I'm running a college database, okay, I've got students, I've got faculty, I've got administrators, and I have other staff members like security and custodians and things like that. And so any one of those different types of people are going to need a name and an address in a city. That's common to all of them. So by doing this, later on, when I make a structure for faculty and I make a structure for administrator, right, each of them can just have an internal structure for personal info, that's got the name, address, city, and I don't have to keep repeating that, right? Our number one philosophical principle in computing is don't repeat yourself. And if I was in a situation where I was going to make a bunch of structures for students and faculty and administrators, right, I might realize, oh, I'm about to put a name, address, city for the student and a name, address, city for the faculty and a name, address, city for the administrator. Well, skip that and make one single package just for that common stuff, and then include that in your other structures as a nested structure. Now you've saved typing time and you're not repeating yourself. And that's exactly why you would want to do that, right? The person info is the common part, common to a bunch of different structures. So definitely we will want to do this once in a while. Okay, so that's the video for today. We covered several things. We covered initializing structures with an initialization list with curly braces. I'm sure we'll see that in a bunch of examples in the future. We covered putting structures in arrays, right? Of course you're going to want to do that because, as I think Alan Perlis said, a program without a loop and an array is not really a useful program at all, right? Programs are really useful when you're dealing with lots and lots of data in an array. So of course you can make an array of structures, and what a relief it is not to have to depend on parallel arrays like we used to. So that's kind of a great relief. Now we finally know the correct way of storing lots of data like that. And we also saw nested structures, right? If you have possibly a bunch of structures that have common components, you could make one master structure and then just include that in all your other structures by nesting. And again, you're going to be seeing lots and lots of dots as you do that. So my students would get together and we would do this lab here on practicing arrays of structures, that very important addition to our programming that happened today. Probably going to happen lots and lots in the future. So we'll get a little practice having that in front of our eyeballs and coming out of our fingers as we type that kind of stuff. And that's important. When we come back next time, we'll be talking about structures and functions. I think a couple times yesterday and in this video, I was saying, geez, I really want to take this program and split it up into smaller parts, smaller functions. And we can finally start doing that tomorrow as we say, can I pass an integer into a function as an argument? Yes. So yes for a structure. Can I return an integer from a function? Yes. So yes, I can do the same thing from a function. So we'll definitely want to be able to do that and pass structures into and out of functions. And then once again, we can modularize our programs, have small little functions that are very easy to read and see on screen at once. And I'm looking forward to that. So I hope you'll join me then.